Hello, Algebra students. This is 2015, and I just realized I needed to make a new video just for my class of 2015. So here we go. You guys be good, work hard, and do your best. Today we're going to talk about using square roots to solve quadratic equations. So if we're using square roots, we're going to see equations with squared terms, right? So we're solving for solutions. Keep that in mind. And so here's an equation where we could solve for x, right? If x squared equals d, what would you have to do to solve just for x? And the inverse of squaring is, very good, you'd have to take the square root. So there's some different things that could happen, right? If we take the square root of x squared, we get x. If we take the square root of d, what are our possible solutions? Let's see. If d is greater than 0, so if d is a positive number, like, let's say it's 4. If d was 4, and we take the square root of d, we get actually how many values when squared equals 4. That's right, we could get plus or minus 2. So when we have a positive value, and we take the square root, there are two solutions. The principal root and the negative root, right? If d equals 0, so if I take the square root of both sides, square root of x squared is x, but the square root of 0 is, that's right, 0, right? So that would leave us with just one answer, one solution for x. And finally, if x squared equals a negative, let's say that d was a negative number, like -1. The square root of x squared would still be x, but what is the square root of -1? That's right, there is no solution. We can't define that, right? There is no value that when you square it equals -1. No integer, okay? So today we're going to isolate the squared term and take the square root of both sides to solve for the unknown. If we have a quadratic equation like this, we'll isolate the x squared and solve by taking the square root. We're ready to try this with some simple quadratic equations. Look how simple this one is. So go ahead and pause, give it a try, come back. So your first step is to, that's right, isolate a squared. So we do this by dividing both sides by 3. 3 over 3 is 1, so we have 1a squared equals 9. And now when we take the square root of both sides to find a, the square root of a squared is a, and the square root of 9 is plus or minus 3. Two solutions here. Solutions are x-intercepts. There we go, we got two of them. Let's try it again. So you subtracted 12 from both sides of the equation, and p squared equals 0. So we undo the squaring using the square root, and p equals 0. How many solutions? One solution. One x-intercept, the vertex. And finally, add 3 to both sides. Remember to pause the video, right, and try these things yourself, right? And now to isolate a, we take the square root. And the square root of a squared is a, and the square root of -1, there is no number multiplied to itself that equals -1, so no solution. No solution there. Okay, that's actually our definition of an imaginary number, right? Square root of -1. Okay, what if we have a fraction? Well, if we have a fraction and we recall the quotient property, right? And what could we do with this? Well, we could separate the numerator and denominator each into their own expression. These two things are equal, right? And of course, we could take the square root of a squared, which is a, and the square root of b squared is b. That's right. Don't forget that we would have plus or minus when we're dealing with fractions as well, right? So let's see how this works. Square root of 50 over 2. Now, is 50 a perfect square? Nope. How about 2? Nope. So this might be a good time to bring the two separate radicals into one fraction, right? And let's just simplify it as a single fraction. So what is 50 divided by 2? You got it. 25. And is that a perfect square? Yep. So the square root of 25 is plus or minus 5. So that's a cool way to use your knowledge of fractions with square roots, right? Here we have what looks like multiplication, right? An equation involving multiplication. So go ahead and try this and come back when you're ready. So you probably isolated the variable through division, right? And we have 1s squared equals 49 over 25. Okay, so how can we get s alone? That's right, we take the square root. So we have s popping out of the radical, and we can see that we've got two perfect squares, don't we? The square root of 49 is plus or minus 7, right? And the square root of 25 is 5. So again, plus or minus 7 over 5. Now it's plus or minus 5 as well, but you will only have two solutions here. And that is either positive 7/5 or negative 7/5. Can we make this more fun? Oh, yes, we can. Here's a more interesting equation to solve using square roots. And let's see what you can do. And together, what would be your first step in isolating x squared? That's right. Add 10 to both sides of the equation. And when you do, 2x squared equals 16. How do we isolate x squared? Undo that multiplication. And x squared, 1x squared equals 8. And how can we isolate x? Take that square root. The square root of x squared is x. And now we have something interesting. We have the square root of 8. That's not a perfect square. So, in this section, if you, one possible answer could be plus or minus the square root of 8, just leaving it in radical form, right? Although we would have to simplify that radical, right? And there is a perfect square factor in 8. So we would say the square root of 8 is the square root of 4 times 2, right? And so what is the square root of 4? That's right, 2. Plus or minus 2 times, we would leave that other 2 inside. So you can recall your simplified radical form, right? The other option is to give an approximate value for the square root of 8. And so, remember FDAD? Square root of 8 is between what two perfect square numbers? It's between square root of 9 and square root of 4. And so, the square root of 8 will be 2 point something, right? Because the square root of 4 is 2, and the square root of 9 is 3, the square root of 8 is between 2 and 3. 2 point something. And will it be closer to this? Will this whole value be closer to 3 or closer to 2? Well, 8 is closer to 9, so it's going to be a value that could round probably to 3, right? So something greater than 2.5. And so what is your estimate? If we're going to the 10th place, maybe we would say 2.8. Is that what you said? Plus or minus 2.8. If you did, you are correct. That is the approximate square root of 8 to the 10th place. And again, we would have a positive 2.8 and a negative 2.8. In your assignment yesterday, where you were approximating the x-intercepts by graphing, you found values between integers, didn't you? Like something between 2 and 3 on the graph. This is a way to find the x-intercepts using your square root rather than approximating by looking at the graph and saying, what is it closer to? So very good. You're ready to go and have fun. This isn't too long. Do your best. Be your best. Be determined. Be honest. Be focused. Be positive. Have a good day.